Okay, in this problem we're going to find the zeros, or find the x-intercepts, or find the roots. All of those are instructions to do the same thing, of the general quadratic f of x equals a x squared plus bx plus c, where a is not equal to 0. Notice if a was equal to 0, that term would disappear, and we'd just have a linear function. So we'd be dealing with that differently. So finding the zeros, that's when the output is 0. Another way to say that is find the x-intercepts. That's where y is equal to 0. Those are also called the roots. So these are all essentially setting this thing equal to 0. I might subtract c over to the other side to start with. I'm really trying to get x by itself, so maybe I'll divide by a. So negative c over a equals x squared plus b over ax. Now, I'm going to have to use a technique called completing the square here. So I'm going to add something to this side. To keep it equal, I'll add it over here also. And it's needed to make this a perfect square. Now, I take this, b over a, and I take half of it, then square it. How do I divide b over a by 2? I multiply by 1/2. So b over 2a squared. Take some time to think about that if you need to. B over 2a squared. Now the whole point of that is so that I can factor this side as x plus b over 2a times x plus b over 2a, or x plus b over 2a squared. If you think about multiplying this times itself, x times x gives me that. X times b over 2a plus b over 2a times x gets me 2b over 2a, reduces to b over a, x. And then, of course, this squared gives me that. How do I combine these two terms? Well, this right here is b squared over 4a squared minus c over a. So to get a 4a squared in the denominator, I suppose I would need a 4a over 4a. Okay, so what I could do, I guess I could write this as b squared minus 4a times c all over 4a squared equals x plus b over 2a squared. Now, I don't know whether the piece inside here is negative or positive, so I'm going to take the square root of both sides, but I'm going to allow for the fact that this could be negative or positive by putting a plus or minus over here. Why do I put it on that side? I'm trying to get the x by itself. Okay, so one side or the other needs it. I'll put it on the side far from the x. Now this b over 2a, I'm going to move to the left side, negative b over 2a, plus or minus. What could I do with this term? Well, you can separate a square root of a fraction to the square root of the numerator, b squared minus 4ac. I don't know how that got sloppily written as an x. So we have 4ac, 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 divided by the square root of 4a squared, which is 2a, equals x. So that simplifies to x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That formula in the box is commonly known as the quadratic formula. And the nice thing about it is you don't have to do this completing the square process all the time. It's achieved by doing the completing the square process, but now that we know it once and for all, if I get something that has 3x squared plus 4x plus 5, I can put 3, 4, and 5 in for a, b, and c and use the quadratic formula. It always gives me a solution, and the interesting thing about that is I can sort of tell you what that is using this term under the square root, b squared minus 4ac. If that term is greater than 0, can you see that I'm going to get the square root of a positive number added and subtracted? That's going to give me 2 real solutions. B is a real number, add a real number, I get another after dividing by that. B is a real number, subtract something, I get a real solution. Now, if this thing is equal to 0, then I get negative b plus 0 and negative b minus 0. Those are both solutions, they just happen to be the same real solution, so one real solution. Now, depending on whether you like complex numbers or not, if this under the square root happens to be less than 0, you could either say I have 0 real solutions, that would be true, or if you want to think about complex numbers, you could say I have 2 complex solutions. So you don't have real solutions, so they don't show up on, say, the xy coordinate plane, but you do have 2 complex solutions. There you have it.